Hello, thank you for joining me. Today we're talking about partial derivatives, which are a way of estimating the slope of a function f of xy in either the x or y direction. So the way we do it is like we freeze one of the variables, so either x or y, and we take a tiny step in either direction and see how the slope of the function respond. So let's say we're interested in studying the slope of the function f of xy in the x direction. So this is going to be equal to f over dx, which is going to be approximately equal to a small change in f over a small change in x at a specific point. So let's say the point 1, 1. So what we do is we freeze the value of y. We freeze the value of y at 1, and we look at the value of x. How does the value of x change? And in our case, we are taking a very tiny step in the x direction. So we are moving from 1 to 1.1. So, and we look at surrounding x values. So it's going to be equal to So what this means is that when we freeze y and we take a tiny step in the x direction, the slope of the function is approximately negative 14. We can also do the same thing in the y direction as well. So which is going to be equal to So in our case, we'll be taking this step from 1.0, this very tiny step from 1.0 to 1.1, and we'll be looking at surrounding x values, keeping in mind that the value of x is frozen at 1. So this means the slope of the function f of xy when moving in the y direction and keep x constant is approximately 25.8. We can also be looking at, there are different ways of approximating the values of partial derivative. We can either look at the table like the way we did, or we can look at contour lines, where we look at the 1 point and we move in either the x or y direction. And these are really, this has huge application, especially in economics, where we want to look at how the values or the quantity or the price of a good changes when we freeze either the price or the quantity. And yeah, thank you.